Alright, so I think we're recording. Let's take a look at some of these problems that are exponential functions and their graphs in this Skill 5a and b homework assignment. We start out with matching 12 equations to 12 graphs. Now, before we jump in and do problem number 1, if we have a function that is some base b raised to the x power, if that base is bigger than 1, then it's going to be an increasing function. All of these exponential functions, these basic exponential functions, if there's been no transformation on it, will pass through the point 0, 1. And they increase pretty quickly, but they're going through the point 0, 1. Now, if we have another function that's an exponential function, b raised to some power, but this time let's say that b is less than 1. It's some proper fraction, 1/2 or 2/3 or so forth. If we take a look at what the graph looks like, it is not increasing function. Since the base is less than 1, it's a decreasing function. And it's going to look something like this. But it's still passing through the point 0, 1. Now that's because any base that's non-zero raised to the 0 power is going to equal 1. Alright, so notice the domain for each of these is all real numbers, and the range is positive real numbers from 0 to infinity. Alright, so let's take a look and see if we can match these equations to the graph. So the base 5 is bigger than 1, so I know it's an increasing function. So I'm looking for a graph that is increasing. It's passing. Let's make a table and figure out a couple of points. Like we say, we know that when x is 0, that it's passing through the point 1, that 1 is the y-intercept. But if x is 1, it's also passing through the point 5. So the ones that have this general shape, well, this one doesn't even have the shape I'm looking for. This one's decreasing. That's below the x-axis. That's been lifted up. That's decreasing. That's been shifted to the left. So when I look at these immediately, I narrow it down to the choice 1 or B. 1 or B, A or B, and when x is 1 here, it's hard to see, but it looks like it's just going through something that's less than 2. When x is 1 here, it does look like it's going through 5. So for problem number 1, it matches to the graph of B. Now in problem number 2, we would take this graph of B and reflect it across the x-axis. So we would be looking for something that, looks like this. And accidentally I left that graph off of there, so we don't see it. So if you want to put not applicable or not there, or it's not, the graph for number 2 is not among these choices. It was meant to be. I intended to have a reflection of this 5 to the x, a reflection across the x-axis, but I accidentally left it off. Sorry about that. Now I have another reflection, but this time instead of the reflection being taking the opposite of 5 to the x, the opposite of the output of this function, I'm taking the opposite of x before we plug it in to this 5 to the x. So it's a reflection, but it's a reflection across the y-axis. So remember that in problem number 1, the graph was B. If I reflect this across the y-axis, it still has the y-intercept of 1, but instead of being at 1, 5, it's at -1, 5. And like I say, it's been reflected across the x-axis. So if I look among these choices, it looks like it's right here. choice D. Okay. So now we have this graph of b, the 5 to the x, and it's being lifted up 2 units. So this is a vertical shift up 2 units. So this 0, 1 is now up at 0, 3. And the horizontal asymptote, instead of being the x-axis, it's the line y equals 2. So it looks to be like this one right here in F, taking the graph of B and shifting it up 2 units. All right. Now this plus 2 is in the exponent. It's affecting the domain. Last time the plus 2, you were taking the function from problem number 1, the output, and adding 2. That was adding 2 to the output, adding 2 to the y coordinate. Here we're adding 2 to the x coordinate. And initially, when we learned those transformations, your initial guess might have been that it would have shifted the graph to the right 2 units, but it actually behaves in kind of a bizarre way, and it shifts to the left 2 units. So instead of this being at 0, 1, we're at negative 2, 1. We're shifting this graph to the left 2 units. So that's what we're looking for here. This guy here that used to be, like I say, the graph of 5 to the x used to be at 0, 1, but now we're at negative 2, 1. So it looks to be the graph of h. Alright. What about this next one? Okay, so we'll take this 5 to the x plus 2, this graph of h, and we'll reflect the graph of h across the x-axis. So at this negative 2, 1, we'll go negative 2, negative 1, and we'll look for something that's, oops, it still has a vertical asymptote there of the y-axis. So it's looking like that. And the only one that looks like that, anything similar to that, would be choice E. That the graphs of 6, the graph of 6 is a reflection of the graph of 5 across the x-axis. Now, this one is not, it doesn't really have a transformation of 5 to the x, because I can't rewrite this base as a base of 5. I notice that this base is less than 1. See, 5 was bigger than 1. This is less than 1, so I know that I'm looking for a graph that's a decreasing function. I know that it's going to look something like this. And it's still passing through the point 0, 1, but it's decreasing. Now, is that enough? If we plugged in a negative 1, that would reflect this, and so f evaluated at negative 1 would be 5/3. And that's a little bit less than 2, because 6 divided by 3 is 2. So if I look at these, if I look here at G with this negative 1, it looks to be approximately 2, a little bit less than 2 right there. So I believe that because this is decreasing, and see, this one's too steep right there, that it has to be G. Alright. Now we can rewrite this one. 1 raised to the x power is just 1. So if I rewrite this 1 divided by 5 to the x as 1/5 to the x power, you know, that's decreasing. Well, I can also, if you, instead of thinking about decreasing, if we compare it to this graph of b, if I flip this fraction, I've got to make the exponent negative. So this is the same thing as 5 to the negative x, which is a reflection across the y-axis. And we saw that, didn't we? Yeah. So it was d. So this is just the same thing. This 1 over 5 to the x is just 5 to the negative x rewritten, and we've already said that that was d, that b and d are reflections of each other across the y-axis. Alright, now this one, if I make this exponent positive, I'm going to have to flip this fraction. And this is the same thing as 5 to the x power. We treated that like our parent function for most of these, except for that one that was 3/5. This is the graph of b. It was the one that we started with. It was the graph of problem number 1 and the graph of problem number 9 are the same graph. The equations look different, but that's just, we can make them look the same by using properties of exponents. Alright, so let's think there's like 3 more. Now, 5/3, I cannot write that as 5 to the x, so I really can't make a comparison, a transformation, of the graph of b. 5/3 is an improper fraction. This is bigger than 1. So I am expecting it to look similar in shape to the graph of b, but since this base is smaller, it'll be that shape, but it just won't rise as steeply. It's not increasing as quickly. So right next to it here is a graph that has the same shape, but it's not as steep. It's not shooting off as steep like b is, where that base was 5. This base is smaller of 5/3. It still is bigger than 1. It still is an increasing function. So the graph for number 10, among these choices, it has to be the choice of A. And if we look when x is 1, 5 divided by 3 is slightly less than 6 divided by 3, which is 2. So here at 1, you're just slightly under 2. Yeah, and that looks to be the case. Alright, now let's take a look at number 11. 2 transformations going on here to this graph of 5 to the x. Both of them are affecting the y-coordinate. That we're not, we're inputting x and then we're applying these transformations. So the first transformation is a reflection across the x-axis, which is going to push this, reflect this across the x-axis, and that 2 is going to lift that up 2 units. So if this goes up 2 units, it looks like it's choice C right there. I don't have anything else that's going down like that that's been lifted up 2 units. Yeah, it has to be choice C. The 5/3 to the negative x power is the same thing if we flip this and change the sign of the exponent as 3/5 to the x power, and we already answered that. We already had the graph of 3/5. The graph of 3/5 was G matched to G. So this is G. So that's it with the matching, and I'm going to stop and put the other problems on another video. So hey, I hope that helps, and I'll talk to you later.